Hi everyone. So today we will be discussing about some important pre-processing or analytical steps that one must not forget about before jumping on to training out your models in any data science projects. So let's get started. So the first and the foremost being you must know your data. Now this gives an idea about what is the data type of the features, how many features are there, how many null values are there, what is the size of your data set. Eventually, there are two different functions that are already provided by pandas that can give you these insights. One is info. It gives you an idea about the data type, the total number of features present. Apart from that, there is a function describe that works only on numerical features, giving you a basic statistics around them, like mean, the 25th percentile, 75th percentile, giving you an idea of whether outliers can be present or not, or their mathematical range. The second most important step is like filling out missing values. Missing values can be filled by multiple ways like mean, median, and mode, or like using some library for imputing values. Eventually, you must be very careful with filling in values, as people usually follow up use me to fill in values. But like for example, in case of categorical data, if we represent categories into numbers using label encoding, so what they would become is cat becomes one, dog becomes two. Now eventually if you go for a mean, it might come out that the mean would be 1.5, as there is no category equals to 1.5. Here your system becomes wrong, so eventually you must be very careful while filling out missing values as well. Check for outliers. Outliers can be disastrous for your model training because the model can go real wayward and results can be very poor because of that. Now, outliers can be easily detected using the z-score method. That's the most naive one, but you can go for complex method as well. Now, any value that has a z-score, absolute value greater than 3, should be definitely considered as an outlier. Now, dropping out unimportant columns. So, if you must have heard of the term that the curse of dimensionality. So, eventually, using unwanted data in training your model is of no use. So, if you feel there is a particular column that is making no sense, for example, ID, ID column, or there is a column that has constant value throughout the data set, these columns can be dropped off. Converting categorical or strings into numerical values. Now, this can, like usually at a beginner level, are done using one-hot encoding or label encoding, or eventually you can go for word embeddings as well. The more complex system you use, the better the embeddings can come out. So, one-hot encoding or label encoding may not be able to capture the meaning of the words as better as word embeddings generated using some transformer or using word 2 So, and this is something that we need to take care of. But initially, you can go with label encoding or one-hot encoding as well in initial projects. Now, the next one being a very important being feature engineering. So, at times there's a case that in our data set we have a few set of features, and there are a few set of features that we can generate using some mathematical operations. For example, if the area of each floor is given, then we can have an estimate ki how big the house is. Now we can use some mathematical equation to generate a new feature called as total area of the house. Feature engineering becomes very important if we are able to add out new meaningful features. The next one being like looking in case of regression problems, there is a problem called as skewness and kurtosis that needs to be checked out. When you feel any abnormality in the target variable, apart from as it doesn't look like a normal bell curve, eventually it can be due to presence of skewness and kurtosis, which can be removed using applying some log transformation or box Cox transformation that you can read out. The next being scaling. Scaling is also very crucial because it can be the case that due to high magnitude of some variables, the model is completely driven by them. So, for example, if you have two variables like say age and income present, now income can be in thousands or even lakhs, while age is a number that would be somewhere around 0 to 100. Now, if these values won't get scaled, what will happen is that the model may get driven by the heavier values, the bigger values, and it can be the case that the income drive all the classification. So scaling is required. We also need to figure out correlated features present in the data set. Feature correlation is also important, and dropping and not dropping those columns It's something that we need to check with the final iteration. But eventually, we must have in our head that these two columns are correlated, and if results can be improved by removing them. So it's an iteration that we should definitely check out. The last one being the dimensionality reduction. So if you have a large number of features present in your data set while the number of samples that you have is low, now it can be the case that model won't be able to understand anything because of the complexity in the data. So you wish to reduce the dimension of the data to something small, and in that case, methods like PC or tsne can be of great help. Now finally, the case of imbalance data sets, the presence of imbalance in the target data set. Now it can be the case that, like for example, spam mails present. So most of the mails are of use, but eventually there is a small number that would be spam mails. So while training, the model won't be able to get enough samples for the minority class. So that is called as an imbalance class. So to maintain that as well, we need to do some sort of an upsampling of the minority class or downsampling. Upsampling means increasing the samples of the minority class, either artificially like duplicating the data set, or like if we are able to fetch out some data, then that's great. Or downsampling the majority class. So for example, if a class has 10,000 samples for one class and 100 samples for other class, it might be the case that your model won't be would be predicting always a majority class because it's trained on most of that data from coming from a particular class. So imbalance, removing imbalance is also very necessary.